Okay, so we just finished the completing the square, and the completing the square, oh look, there's a major typo here. Completing the square leads us to a really cool formula called the quadratic formula, and there's if you search through there it is, through their songs about the quadratic formula. I'm not going to sing here, but if you anyway, using the completing the square, you can work around to get to this, and there are a lot of good videos. I've had them out there also that show the derivation of this formula. So if you have ax squared plus bx plus c equals 0, so you have to have it equal to 0, then with those coefficients a, b, and the constant c, you can find the zeros of this polynomial, or the solutions, the values that make this a true statement, the following way. It's negative b, the coefficient x, negative b, plus or minus the square root of b squared minus 4ac all over 2a. Now, this gives you two solutions because it's negative b plus that square root of b squared minus 4ac all over 2a, and then negative b minus the square root of b squared minus 4ac all over 2a. So it's two answers there. So let's go ahead and try that with this problem. We have two problems here. So first thing to do is identify what is our a is 9, our b is 3, and our c is negative 2. So the quadratic formula says negative b, that's 3 in this case, plus or minus the square root of b squared, so that's 3 squared, minus 4 times a is 9, times c is negative 2, all over 2a, and a is 9 again. So at this point, this is a very, I almost want to call it a mechanical way to grind this out. It's just you go through the calculations. It's a little less elegant than factoring or even completing the square, but it gets you there. So we have 3 squared is 9. So we have I have 4 times 9 is 36 times negative 2 is a negative 72. All over 18. 2 times 9 is 18. So x is negative 3 plus or minus the square root of 9 minus a negative 72. That's a double minus a negative makes it plus. 9 plus 72 is 81 all over 18. So it's negative 3 plus or minus the square root of 81 is 9 all over 18. So we have two answers. Negative 3 plus 9 over 18 is 6 over 18, which is 1/3. Negative 3 minus 9, I'm going to do a little comma here, all over 18 is negative 12 over 18, which is negative 2/3. So our solutions here, our x would be 1/3 and negative 2/3. And the next problem, I need to get this 3k over there and the minus 4 over there. So I'm going to add 3k to both sides. I'm going to add 4 to both sides. So I have 4k squared plus 3k plus 4 equals 0. So my a is 4, my b is 3, and my c is 4. So k is going to be negative b is 3, plus or minus the square root of 3 squared, so that's b squared, that's 3, minus 4 times a is 4, and c is 4 as well. All over 2 times 4. Okay, so I need to simplify what's under the radical here. So it's going to be k is negative 3 plus or minus the square root of 9 minus, and 4 times 4 times 4 is 64. All over 2 times 4 is 8. So it's negative 3 plus or minus, and 9 minus 64, I believe, is 55, negative, all over 8. And the 55, you can't do much with that. I mean, it's 5 times 11. Neither of those are perfect squares. They're both prime. So the best I can call this is negative 3 plus or minus, I can bring the negative out and call it I times the square root of 55 over 8. But those are our two solutions, the negative 3 plus I root 55 over 8, negative 3 minus I root 55 over 8. That's it. So neither of those solutions are real. This is a complex solution. Now I want to move on to the discriminant. That's the portion of the quadratic formula that's under the radical, the b squared minus 4ac. And if you can look at the discriminant and figure out what it's going to be, like this last problem is a good example of it, it can tell us what the solution is going to be. So if you have the situation where b squared minus 4ac is 0, you have one solution, because that's like saying you have like 3 plus or minus the square root of 0 over 2, so it'll just be 3 halves, for example. If it's greater than 0 and a perfect square, meaning you can take the square root, there's nothing left, you end up with two solutions. And that was that first example we had up here, is that it ended up being an 81 under there, so square root of 81 is 9. So that cleaned up nicely. So two rational solutions. If it's not a perfect square, then you're going to end up with something like, 3 plus or minus the square root of 21 over 5. So here you have two irrational solutions, because you're looking at 3 plus the square root of 21 over 5. That's irrational because of the square root of 21. And 3 minus the square root of 21 over 5, also irrational. So let me just say examples. Now, this last case here, b squared minus 4ac is less than 0, meaning it's negative. And that's what we had in this last example, so it's nice to be able to refer to that. We had a negative under the radical. So that's going to give us the complex solution. A complex number is a combination of real numbers and imaginary numbers. So that's the last example. Let's just call that example 6. I call this one example 5. So now this last little exercise is to use the discriminant to find the nature of the solutions to the following quadratic equations. So here a is 1, b is 4, and c is 4. And some of you are probably screaming at your screen right now saying, oh, I know exactly what that is. I can tell. I could factor it in my head, but not everyone can go there. So just be patient. So again, we're looking for b squared minus 4ac. What's that going to be? So what do we have here? B squared is 4 squared minus 4 times our a is 1 and our c is 4. So 16 minus 16 is 0. Okay. Being 0, that means we're in the first case that there's one rational solution. One rational solution. The next one, our a is 8, our b is 14, and our c is 3. So b squared minus 4ac is going to be 14 squared minus 4 times 8 times 3. So that's 196 minus, let's see, 4 times 3 is 12 times 8 is 108, right? No, 96. We know that. 196 minus 96 is 100. And that's a perfect square. So we have the second situation. So it's greater than 0 and it's a perfect square. So this means you have two rational solutions. Next case, we have a equals 3, b equals negative 5, and c equals negative 2. So our b squared minus 4ac is going to be negative 5 squared. So remember what happens when you square negative, the negative goes away. Minus 4 times 3 times negative 2. So that's 25 minus, so 4 times 3 is 12 times negative 2 makes it negative 24. So minus 24. So double negative makes it 25 plus 24, which is 49. That's a perfect square. So this is case 1 or case 2 where you have 2 rational solutions. In our last case, let's see what that's going to be. We have A is 3, B is 10, negative 10 I should say, and C is 15. So we're looking at B squared minus 4AC. We're looking at negative 10 squared minus 4 times 3 times 15. So 100 minus, and then 4 times 3 is 12 times 15 is 180. So we get negative 80. And this would be the last case. So we have 2 complex solutions. Okay, and that's how it works. Okay, now have fun with that homework, and next we'll be doing 4.3. I'm trying to think, where am I working right now? Okay, have a good day.